Hello, everybody. I'm Jeff Tao, the founder and the co-developer of TDengine. Today, I would like to take an opportunity to give a presentation why we need a new TimeSeries database. Let me share my screen. What is TimeSeries data? TimeSeries data is a series of data points listed in time order. There's so many TimeSeries data in our real life. For example, the stock market, the stock price is changed all the time. And like for transportation, logistics, the location of the bus, the location of the truck are TimeSeries data. For manufacturing, SCADA, PLC, generate tons of data. And also for connected vehicles, like for the T-box, for the motor status, for the battery status, they are all TimeSeries data. And also for IT monitoring, we want to know the CPU utilization, memory usage, network status. They are all TimeSeries data. And of course, for our energy industry, no matter for like a clean energy or just the grid, they generate tons of TimeSeries data. Okay, with the growth of IoT, many devices are internet connected. So the data generated by internet connected device already surpassed the non-active devices. So the TimeSeries data is growing exponentially. Okay, to process those TimeSeries data, of course, we can use traditional database or even NoSQL database, but they are not efficient enough. So engineers in the world invented a purpose-built database. It's called the TimeSeries database to process those TimeSeries data efficiently. Okay, now on the market, there are already many TimeSeries databases on the market. For example, InfluxDB, TimescaleDB, QuestDB, Prometheus, and also our TDengine. There are more than 20 TimeSeries databases on the market, and also most of them are open source. Then the question, and also it means the TimeSeries databases are gaining more and more attention from engineers, from venture capitals. Look at this diagram, the rise of TimeSeries database. For the past 5 years, the momentum of TimeSeries database is very big. So it attracted many eyeballs. But there's so many TimeSeries databases on the market, but they are good enough? Are they perfect? They solve all the problems? That's my major topic today. My answer is no. Okay, first of all, most of the TimeSeries databases on the market are not scalable. For example, InfluxDB, so open source version is not scalable. They only keep the scalable edition for its enterprise solution. And also QuestDB is does not support class, is not scalable. OpenTSDB is the only open source distributed solution for TimeSeries data. But OpenTSDB, it's very slow. Their performance is not good enough because it's based on HBase. Another thing is high availability. This is related with the scalability because you don't have a distributed design, then it's impossible for you to provide high availability. You must have a distributed design. You must provide a replication. So in case a machine or container crashes, the service won't be interrupted. We need high availability. Another one is all those TimeSeries database has very good performance compared with traditional database, but the performance are still not good enough. It still has room or it still has space to improve. Another gap is query language. For the most popular time-series database, like InfluxDB or Prometheus, they use proprietary query language. SQL is not used, but SQL is the most popular query language. If you use your proprietary query language, developers got to learn, and also the migration cost is high. Another one is it's very complicated system. In our modern data infrastructure, database is only one component. Okay, to process time-series data, you still need like a message queue, you need a stream processing, you still need a data subscription module. So besides the time-series database, you still need to integrate many other components into your system. Then the whole system becomes so complicated. Of course, cost is very high. And also maintenance is not easy. So the total cost of ownership is still high. But so I think we need a new time-series database because there's so many problems. But what's the requirement for a new time-series database? I think the first thing is it must be developer friendly. If it's not developer friendly, developer won't like it because it takes them time to learn how to make it developer friendly. First, number one, you need a very flexible data ingestion. Why Prometheus, why InfluxDB or other NoSQL database becomes popular? Because they don't need, they can support schema lists. You don't need to define schema in front. You can just insert the data into the database without the definition of the structure. So it's very flexible. So every new time-series database must support schema-less data ingestion. And also the second thing, I think, is query language. For a new time-series database, it must support SQL. SQL is still the most popular query language. Third one, you must be an open system. If you don't open source your time-series database, developers won't like it because now open source is eating the world. And also, I'm a developer too. Every developer just like a copy and paste. They don't want to do many things, right? So you need to have a zero management. Once I deploy the system, I hope trouble-free. I don't need to spend much time to manage the database system. So that's very, very important. Second thing is cloud is very, very popular now. A new time-series database must be cloud native. For cloud native, the number one fact is the system must be scalable. You can scale up and also you can scale down. You only need allocated resources for the business required. Okay, you must be able to scale up or scale down. The second thing is I already talked about the high availability. It must be there is no downtime, or in other words, it must be you have very good resilience. Okay. Now, number three is you need to separate compute from storage. Okay, and also everything can be dynamically allocated. The computer resources and the storage resources are decoupled. They can be dynamically changed. Okay, and the number four is you need a very good observability. Otherwise, it's very hard to manage your database. Number five, in the cloud environment, you must have a very good automated environment. Everybody can use API to manage the whole system. Okay, they don't want to do that manually. They need to do that in everything in code or in environment. That's very important. Okay, and also there's still other requirements for new time-series database. Number three is performance. I said compared with the traditional database, the performance is already good, but there's still lots of space to improve. Number one is you need a very good ingestion rate. Number two, your query latency should be small. Number three, you need to improve your storage efficiency. You need a good data compression ratio. Number four, beyond the database, other components is needed for a modern data infrastructure. Like what I said, stream processing, caching, data subscription are all needed for time-series data processing. So new time-series database better support those features. So I just talk about the requirements for a new time-series database. But there's so many challenges to implement a new time-series database. I think the number one is the large data volume. For example, in mainland China, there are over 1 billion smart meters. Every smart meter generates a data record every 15 minutes. Okay, so every day, every smart meter generates 96 data records. You only have 1 billion smart meters. Then how much data you got every day? So there is a very, very large data volume. Just think about autonomous driving. Every car generates a few gigabytes data a day. Then all the cars together, how many data you generated? So your system should be able to process very, very large data volume. Okay. And the second thing is you need to support high cardinality, because you have so many smart meters, you have so many cars, you have so many smart devices. Every device has a set of tags or static attributes. And also we need to do multi-dimensional analysis. And I want to analyze the smart meter based on locations. I want the smart meters based on hours or even based on business. So the cardinality is a big problem. Okay, and to process a large number of devices, it becomes a big challenge. And number three is for time-series data, you need to do real-time computing. Without real-time computing, it's almost useless for IoT platform, because you monitor everything. You want to raise the alert in real time. If you can only do batch processing, you process data after one whole day, it's almost useless, because you cannot raise the alert in real time. The accident already happened, right? Number four, you need to support a complex query. You just because now there's so many data scientists on the market. They want to query. They want to do all kinds of multi-dimensional analysis. They want to generate all kinds of query reports. So simple query are not good enough. Okay. So to solve all those challenges, what do we do? I think we do have ways to solve all those challenges. Then we need to check what is really, what's the characteristics of time-series data. If we study more on time-series data itself, we may find a solution. Okay, time-series data. I wrote a blog a few years ago. I listed 10 major characteristics for time-series data. First of all, time-series data is always time-stamped data, of course. The second thing is for time-series data is always structured data, not like social media, like for WeChat or Facebook or LinkedIn. The data sometimes image or text or some videos, but for the data on the stock market or from devices or from sensors or from vehicles, they're always structured, okay, like a float or integers or status. They won't be changed at all. It's always structured data. Number three, the data source is like a string. Okay, just like a video camera. Every sensor or device generates the data in a predefined rate. Like for example, for the smart meter, they generate the data every 15 minutes. Or like for electronic vehicles, they generate data every 10 seconds or 15 seconds. Okay, and number four, data rate is pretty stable. Unlike e-commerce, for example, during a holiday season, the traffic to e-commerce site becomes very, very high, right? But for IoT devices, okay, for time series data, as long as your sampling rate is there and the number of devices there, you can calculate how much data they can generate, okay, every day, okay. Number 5, compared with relational database, time series database don't need to support transaction, okay. That's the easy part. Number 6, you always have more rights than read operation. Like for Twitter, every post can be read by 1 million like readers, right? But for the data generated by smart meter or the data generated by a clean energy, few people read the raw data. You can just apply your Python algorithm to analyze the data. You want to read the raw data, okay? So there are more writes than read operations. Write operations are very important for time series data. And also, data is rarely deleted or updated. Theoretically, time series data should not be changed at all, but in very few cases, some engineers or developers still want to delete or update the time series data, but the probability is very, very small. Okay. Number 8, although we don't want to delete or update the data, but we always want to keep the data for a just for like for a period. Like I want to keep the data for half a year or 1 year or just for 1 week. That's a retention policy. Retention policy is always applied to time series data. Number 9, I already talked about that. Real-time data computing is desired. Otherwise, it's impossible for you to raise the alert. Okay, and number 10, the characteristic of time series data. Query is always in time and the time space range. You want to run a query for all those historical data. You always run your query for the past a few minutes, for the past day, for the past year. So you always set a time range for your query. Okay, so I think if we apply all those characteristics of time series data into a new time series database, we can improve the performance. We can meet all those challenges. I just talked about that. Okay, so almost 5 years ago, I started about this business, TDengine. So I think it's time for innovation. It's time for a new time series database. So in year 2017, I started the business TDengine, and also I'm the developer. So I wrote the first 20 lines of code. Okay, let me share with you a little bit about our TDengine. First of all, TDengine is an all-in-one time series data platform. The core part is still database, is a time series database, but it also it provides caching, stream processing, and the subscription features. So if you use TDengine as your time series database, you don't have to integrate Kafka or Redis or Flink, Spark anymore. Then your total cost on development and also your cost on operation will be significantly reduced. Okay, that's the ecosystem for our TDengine. On the left side, it's a data source, like a telegraph can write the data into TDengine seamlessly. Kafka, OPC-UA in manufacturing, okay, MQTT broker can all write the data into TDengine. On the right-hand side, like a visualization tool, like a Grafana, can be integrated with TDengine seamlessly, and even Google Data Studio can be integrated seamlessly. And of course, it supports SCADA, HMI, and also it has connectors with Python, MATLAB, and R for data scientists. And of course, you can connect your IoT application with TDengine. Okay. And also, because we only have 20 minutes, I don't have time to share more details about our product. I just get, so I just want to introduce you a little bit since unique about the TDengine. First of all, our data modeling is very unique. Okay, we have a data model. Okay, it's relational data model, but we require the user to create a table for each device or for each data connection point. By create a table for each device or each data connection point, it will improve the ingestion rate significantly. And also it improves the query performance significantly. You can check my blog why, okay? And also we have another new concept is called the soup table. Soup table actually is a template for a set of devices, okay? Yeah, so when you create a table, you always use a soup table as the template to create it. And also, soup table is used to aggregate the same type of devices together. It helps you to aggregate the TimeSeries data generated by the same category of devices. Okay, and number three, the unique part is I said I already talked about that is all in one. So it makes the architecture simpler. Why we can do all like this? Because we explored the nature of TimeSeries data. It's a highly optimized design. So TDengine is a highly optimized design for TimeSeries data. And also our performance is very, very good. Compared with general database, the read-write performance is 10 times higher. And also even compared with the most popular TimeSeries database InfluxDB, our data ingestion rate is like 2 times to 5 times higher. And also the majority of our queries are fast and sometimes are 40 times fast. Okay, and our compression ratio is like 70% higher compared with InfluxDB. Okay, and also, of course, it's scalable. Okay, we have a relative distributed design. It supports both sharding and partitioning. A shard contains data for multiple time series. For example, a shard may contain 10,000 smart meters. Okay, another shard contains the data from another 10,000 smart meters. And also we support partition. Partition contains data for a time range. For example, a partition contains data for just one single day or for a single week, okay? And a physical node or just like a computer server may contain multiple shards, okay? So by supporting both sharding and partitioning, TDengine is a scalable system, okay? And also, it's a very beautiful thing for TDengine is from day one, we serve to SQL, okay? So, and all our syntax is just like MySQL. If developers use MySQL a lot, low learning curve, low migration cost. And also, we support every major programming language like C, C++, Java, Go, Rust, Python, Node.js, and of course we support RESTful APIs. And also you can run ad hoc queries through TDengine shell. Okay, just let me give you an example. Just exactly just like MySQL. You can create a database, you can create a table, then you insert the data into the table, then you run your queries. It's very straightforward and it's very simple. Low learning curve, low, very small migration cost. And another thing I want to share is our TDengine core are fully open sourced. We opened the open source our single load edition in 2019, July 12. And also then we opened our cluster edition in 2020, August. Up to now, we already gained more than 18,000 stars on GitHub. We already have more than 4,000 forks. And also, we have over 10,000 issues on GitHub. Within just 3 years, Okay, and also every day there are over 1,000 clones on GitHub, and also every day there are over 200 new instances running over the world. Okay, I'm very proud with those numbers. It means our TDengine are very, very popular. And also, that's my presentation today, because we only have very short time to share. You can follow me on Twitter or LinkedIn. That's my link. You can scan my QR code. And also, you are welcome to visit our website to learn more about the TDengine, and also you can join our Discord channel to have lots of discussions, technical discussions with our whole team. Okay, thank you.